let's get started. Have a calculator ready. You're going to need it quite a bit actually here. So far we didn't really need this all that much, but for what we're doing now, yes. Make sure you get everything ready, guys. Booklets. I don't know what the province is going to do. Sometimes they give you the conversion rates, but most often they have not. So I would strongly suggest to have these ones on your study sheet. I don't know if I mentioned it on the video, and remember your job was to fill in 3 to 9, pages 3 to 9. However you did that, it's up to you. I hope you did it, because if you didn't, today you might scratch your head on some of the things we're doing. If you did the conversions here, great, but I think I can just sneak it in as we do the questions, because it's not predominantly a thing. Here's another one I want you to add to your study sheet. You ready? This one here. 1 cubic yard has 27 cubic feet. This one is, if there's a popularity contest on the exam, this one is it. This one right here. The province likes this one a lot. And let's do this one here. 1 squared meter has how many squared centimeters? Anybody? 1 meter has 100 centimeters, that is right, but squared. What do you do when something is squared? You literally square the whole thing. So 1 squared meter has 10,000 squared centimeters. So you gotta watch out. Don't just think, oh, a meter, it's 100. If it's meters. If it's squared, you need to go with what you know and square it. So this is another one that I would say have it on your study sheet just in case. So you've been warned. These two, as well as this whole table at the top here. You got it? Okay, I'm going to page 13. Skip, skip, skip. Okay. So we're going to talk about composite shapes, hollow shapes, etc. And we're going to start with just diagrams, and then we're going to turn it into word problems. Now that we've reviewed and derived formulas, important steps that you want to, 13, yeah. When you deal with this, and this is, I don't think you need to have this on your study sheet, but I will show you what I mean by this. I would write down all the sides that you need to include and which ones, follow along, okay? Which ones need to be subtracted or omitted, okay? I would strongly suggest you write down the formulas that you will be required. Include formulas for the faces that you're subtracting. If you choose to solve everything separately, do not round too soon. I'm going to give this a different color. Some students like to do everything like in chunks and all over the place. Just do not round too soon. I would say 4 decimals. This was before the awesome calculators you now have. I would say use all decimals. We can copy paste. It's so easy with these ones. The older ones, it was a pain. Okay. Make sure you check if your answer makes sense. When multiple shapes connect, do not include that portion. So don't double count. That's what I'm trying to say here. This is gonna make your head. This is gonna challenge you a little bit. Because sometimes you're not gonna see what I see or what I'm telling you you're supposed to see, And that's okay, you're just gonna have to practice to get good at it. So let's do the first one, composite shapes. In fact, everything that follows, we're gonna do basically the same thing here. We're gonna figure out surface area and volume. This is on 14. A company needs to produce cardboard boxes as depicted below. Calculate the amount of cardboard needed. Hint, how much material is needed to construct. What would you call this, volume or surface area? Surface area, okay. So surface area, because sometimes the province will not say what it is you're supposed to find. They will just assume you will know within the context. But that's surface area for sure. B, what would be the capacity of the box? Hint, how much would fit in it? Volume, okay? So you're always going to be between these two. Is it going to be areas or surface area, or is it going to be volume? Before I start, I also hope that the formulas that are between pages 3 and 9 you need to have on your study sheet as well, because they will not give you the formula. Okay, the province will not give you the formula. If it costs, I don't know what happened there, I'll do it later. Let's just do the surface area. Volume is easier. Let's do volume first. Okay, volume is easier, trust me. So if we go with volume, we would go volume of cylinder plus volume of box. Would you agree with that? Sure, I would. Why wouldn't I, Mr. Dirksen? Okay, let's do this. What's the formula for volume of a cylinder? Pi h plus length times width times height. Here you have to be careful. H and H. Problem. So I don't know what you want to do there. You could probably say, I'm sure you're not going to mix that up, but this is the height of the cylinder. This is the height of the box. If you want to do that or put a number down there, that's fine. So let's do this part. Pi, radius in this case, everything is in inches. That's another observation I make. The radius is simply, I would just go radius is 1.5 right away. I'll do it right here. So I need 1.5. I need to square that. And the height of the cylinder is 20. Plus length times width times height. So normally by default it's length, width, and height. If we give you the information in that order, that's what we would assume. Even though for volume it doesn't really matter. So grab your calculators and let's do this. Where's my calculator? Oh, right here. So I would do this part and that part separately. So there's a pi button. You got to press second and then the hat button right here. So second and hat gives you pi. You can't just use 3.14 because you're going to lose marks for rounding. And then I just use brackets. Brackets are your friend, right? So I go bracket 1.5 squared times 20 like that. And I just write down and you don't need to write down the whole thing. Just go dot, 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 plus, and then you go 10 times 6 times 4. That's 240. What are you looking for? The pi button? Oh, just X2. Yeah, there's an X2 button that squares, okay? If you don't have if you're not squaring, if you're cubing, then use the hat button and then 3, okay? All right, that's 240. So now all you need to do is copy paste, right? Copy paste plus copy paste. So I paste both of these answers with a plus. So that's 381.37. What are our units in? Inches. It's volume. Cubed. Cubed. So that would be the total volume of both shapes combined. That one to me is not too bad. But now surface area. Here we go. Surface area. I will go TSA for total surface area. You do whatever you need to do. Okay. What should we start with? And the answer is doesn't matter, but my example, I'm going to start from the bottom and just go up and see what faces are there. So I'm going to go surface area of the box plus surface area of the cylinder. But there's a problem, okay? Do you see this face right here? Now pay attention to this. If I find the surface area of this box, let's assume for a second this cylinder is not on top of it yet. If I find the surface area of this box, I will include this part here, right? I don't want that. But I do need to include this one up here. So by me just figuring out the surface area of this entire box, we'll take care of for the box and this little circle up here. I'm almost assuming it got cut out of here and placed on the top. Okay? Does that make sense, what I just did? I'll try again once I've solved it. Okay? So surface area of box plus surface area of cylinder, but I got to go minus area of circle. I got to omit one of these circles here for me to get this right. So let's do the box first. 2 times length times width plus 2 times length times height plus 2 times width times height. So one way that I always look, am I doing this right? I want to have one bracket that goes length times width. Then I want to have the other 2 brackets. I want to make sure the height is in there. Right? In this case it's 4. And then I know I'm doing this right. Put that in a square bracket like this. This is the box. Plus surface area of the cylinder. What's the surface area of the cylinder? 2 pi r squared. I'm going to write this out. Plus 2 pi RH. But there's a problem there. Okay? If I do this part right here, I'm finding the surface area of the entire box, including this circle, which is fine because I do want this part here. So I'm taking care of the entire box plus the top here. Okay? So technically, I don't want both circles as part of that. I'm just going to get rid of this. I don't need that. Because this box is already taking care of the one circle that is there. Correct? And I don't need to add another one yet with this formula. So it just comes down to this. This is called the lateral surface area of cylinder. Does that make sense? This is just the side. Like if you were to wrap this cylinder around, like that is what we're doing here. Okay. And so let's compute this now. We got to clean this up a bit. I will already do these numbers here. So what, 10 times 6 is 60, times 2 is 120, plus 10 times 4 is 40, times 2 is 80, 6 times 4 is 24, times 2 is 48. You can type it in all in one shot if you want. So that's 248 plus 2 pi. Radius is 1.5. The height here is the 20, right? The 20 of the cylinder there. So it'd be 248 plus 2 times pi times 1.5 times 20. It's 188.4955, and that keeps going. So then I'm just going to add 248 to it. That's 436.50 squared inches, because now we're talking surface area. And of course, if you wanted to make 1,000 boxes, you would multiply this by 1,000, right? And here's what I'm gonna try to encourage you. This is probably the cleanest, shortest way of doing it. Some students do it very differently. They figure out everything and then they go minus a circle there, minus a circle there. That's okay. If you take a different route to get there, I'm fine with that. As long as you're careful with what you're doing here. I will try. Give me one more chance here to try to make sure, because I know the visual part is hard. So all of this is literally taking care of everything here. Everything here. And I'm almost assuming, right, I'm going to need that circle up here eventually. So by me doing the surface area of the box and not subtracting a circle, it already takes care of that circle up here that I do need. Okay? And then the second part is just the lateral surface area here is just this part. And I also omit that circle down there because I don't want to count it. Okay? This circle here is not to be counted from the box, and it's not to be counted from the cylinder. We do not want this one, no matter what. And this was my way of omitting it, right? I took the box. I'm like, I'm not supposed to have this part here, but don't worry about it, because this part is almost like somebody cut it out and put it on top here. So I combined it into my box, okay? And then I went plus the surface area of just the lateral. I completely got rid of the 2 pi r squared. I didn't need either one because this has already been accounted for. This one I don't need anyways. That's how I got rid of that. Okay? And so this is what it came down to. So when you, if you can at all, try to see, oh, if I find the whole thing, I'm already taking care of that piece that's out there. You can almost like pretend like it got cut out and put up there. That was my second try. Sorry, guys. If it doesn't work, let's do a couple more. Let's go to this one. Shapes with holes. And this one is actually pipes, right? This one is pipes. Let's do the volume, a total exposed surface area and total volume. Let's do the volume first. That one is the easiest. Total volume would be volume of large cylinder minus volume of small cylinder. Okay. And these are all cylinders, so we're just going to go pi. I'm going to go capital like this. R squared H minus pi R squared H. Oh, actually, the H's are the same, right? Would you agree? the height, like, if you need me to explain this, what we're doing here is pretend like this cylinder was completely solid, but somebody drilled a hole through it in the middle, like right through like this. So this is just different views of this pipe, okay? So the height of both the small one inside and the big one is the same. So I'm just gonna stick with capital H, they're the same. But the radii, they're different. One is, right, goes from end to end on the outside, and one is end to end on the inside. So let's try this. Pi, what's the radius of the big one here? Let's do the math here. It's 25, right, from end to end. So radius, the big one, is 12.5 centimeters. Got it? We're told here from end to end, it's 25, so 12.5 is the radius. So let's go 12.5 squared. What's the height of this pipe? 64.5. Okay, minus pi radius. What's the radius? This one is going to be trickier. What's the radius of the smaller? What is it? 10? Okay, I'm just going to show how we got that before. If this is 2, then this is 2 also, correct? 2, that's like the thickness of this pipe. So we're just going to go 25 minus 4. So from end to end, it's 21. Would that make sense? Okay. I know I'm bombarding you. You just had a nice long weekend and now I'm bombarding you with like crazy stuff here, right? So the radius of the that small inside cylinder is 10.5. Okay? Squared. And the height is still the same. And now it's really just type it in and go. The volume is usually easy. So what I'm doing is I'm going big cylinder, take away the small cylinder, that's what I'm left over with. So today when you go home and your parents ask you what did you learn, you cannot say nothing, okay? We actually did stuff today, okay? Do you tell your parents nothing? I hope you don't. So we go pi times 12.5 squared times 64.5. I'm just going to write down, you want to leave a trail of work behind, right? You want to see, like, I should be able to see this is what you're doing, right? So you can go dot, 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 that's fine. And then I'm going to go pi times 10.5 squared times 64.5. That's 22, 340, 25, and something. And then just copy paste, right? You go get the big number, go ahead, minus the small number, enter. That is 9321.11. Now you can round. What are we in? Centimeters? You don't want to lose half a mark just like that. Cube. Okay. Because everything is in centimeters. Now surface area. Are you ready for this one? Surface area is going to be tougher. Here we go. TSA. Let's look at it. So we want everything on the outside. Okay? The whole thing wrapped around the outside. So I'm just going to say lateral surface area of the large one. So everything around the outside. Plus lateral surface area of the small one. Are you with me here? The inside, right? So lateral, lateral. We're doing good? Okay. So outside, inside. So I'm going to add that for sure. Plus I need to account for this little lip here on a top and bottom, right? How would we do that? Let me try something. I hope this works for you. There are two of them, right? There's a lip on this end and there's a lip on the other end, correct? There's one up here, there's one down here. So I'm going to go 2 area of circle of the large one minus, how should I do this, lowercase a? Area of circle, small one. In case you're wondering, what are you talking about, Mr. Dixon? Do you see two circles when you look at it from the top down? So this is area of small one, and this other one is area of large one, right? So that's what I mean. We're going to subtract these two, and then we'll have this lip left over. Mr. Dirksen, are there other ways of doing it? Yes, there are other ways of doing it. And if you're thinking it right now, you're probably all right. If you have a different way of doing this, you go for it. I'm just trying to make it so that you can actually see what's happening. So let's plug in. Now it's all about plugging in. TSA. Lateral surface area of the large one. 2 pi r, I'm going to use capital R, h, plus 2 pi lowercase, and the h is the same, so I'm just going to go h, plus pi r squared minus pi r squared. And there's two of them, that's why I put the 2 in front. So let's plug in. 2 pi radius of the large one, we already determined that it's 12.5. And the height we already determined is 64.5. Plus 2 pi radius of the small one is 10.5. So you've done that work already. Plus 2 times, I like square brackets to just kind of say like, hey, that's a chunk that we're dealing with. Pi r squared minus pi lowercase r, right, squared. And if you can crunch this, right, if after plugging in, if you can just show me what you've done, you're in business. To be honest, I don't have the key for this right now, so I'm going to try to beat you to it. So the first part is, please don't rush, because there are so many things that can go wrong here. It's not worth it. I am copying and pasting. See what I'm doing here? I copied the entry before here, and I'm just going to change my radius to 10. See how that works? Try to find ways to speed this up if you can. Enter. That's 4255. 287. Plus 2 times. I'll do the 2 times later. Let's go pi times 12.5 squared. That's 490.87 minus pi times 10.5 squared. That's 346.36. And here we go. I will first subtract these two back here and multiply it by 2. So I get 289,026. So I give you full permission to do something like this every once in a while. You just say that that's 289.026, right? We've crunched this. That's what it comes down to. And now just add. So I'm going to go copy paste plus the 289, and that's 9,610.13. Are you following me or no? You're not? Anybody got this too, or I didn't make a mistake? And we are in centimeters squared, yes. So you would do something like this if they asked you, hey, you need to paint this pipe. What's the surface that will need to be painted? Here it is, right? They might say you have to paint 10 of these or 100 of these. You just multiply this by 100 or by 10, whatever the case may be. So that is what this section is all about. And I got creative. I used a 3D software to make these. So I'm going to ask you 16 to 18. 16 to 18 to try that on your... They're all very unique, so if I said I would like you to do at least 2, I'd be happy with you trying at least 1 on your own. I would 2 is really good, 3 is perfect. So they all kind of have the same idea. I can't tell you which one is harder than the other, so you're just gonna have to try this. Okay? But we'll continue with this tomorrow. Okay? Thank you, guys. Maybe give this one a start already. Give this one a try. And see how it goes. One sec. Yeah, you can go. Can I just give you 1 second, guys? I'm going to give you one hint. For these triangles, like at the top and bottom, you're going to need the area of a triangle, correct? Which is base times height divided by 2. I hope you have that one on your study sheet. And you may have to use Pythagorean theorem to figure out the height. Anyways, good luck. Try it. Try at least the volume, and then take a closer look and try the surface area.